Alright, welcome. So we're in COP1000 and this is Intro to Programming. Now this little lecture video is targeted for a specific purpose, and it's to give you some specific foundational concepts for this course. And we'll start off with talk about programming, different types of programming and how we use programming, and the different concepts that are applied in programming. Okay. So let's start out with what is programming. Now, a variety of different terms may be used. You may have heard it as, call them coders, programmers, developers, solution developers, software engineers. It's in a sense they're all synonymous. They all mean about the same thing. What it boils down to is some have a higher level or more complex task that they perform. So at the lower level, we'll call them coders or programmers. And it doesn't mean their job isn't complex. We're just keeping things simple. Now in this article that I've got on the screen now, they use the term software developers. Okay. And they talk about why we need software developers and the increased demand for software developers to create applications. And we say, what's an application? What is software? Well, I'm using software to record this video. Somebody has written code to perform a specific task, controlling hardware to yield this digital result. It interacts with my computer display screen, interacts with my microphone. It stores that data and allows you to sit and watch and listen to this. Okay, so with that said, what is software? Well, it's code that's written to control hardware to perform some computer task. Now, the hardware that we're using currently is an operating system, and its primary task is to allow you to interact with the computer hardware. That's what allows you to type into the keyboard, and the keyboard then inputs into the system, and the system knows what you want it to do based on software somebody's created. So in this course, you'll create software. There's some new terminology that has come out with software that's called Orange, and in some courses they program, but there is no code. It's code-free or codeless programming. And we've gotten to the point that somebody has written software, they've programmed an application to allow us to create programs without even having to write code. The application creates the code for us. In this course, we're actually going to create code to perform certain tasks. So one of the names that I said was, well, solution developer. And essentially, what that means is that somebody said, look, I've got a problem, I have a need, I've got something that needs to be addressed. So what do you need to do? Well, I need some software that will display, welcome to Intro to Programming. Okay, so how's that going to work? I just want the user to click a button and it'll display. Okay, so that's the task that we've been given. Now, as a programmer, we'll look at this from what's called the software development life cycle. It's got different stages. And we start out in stage one and we plan what we're going to do. How do we even know what we're going to do? Well, somebody came up with a problem, an idea, whatever, an opportunity. We call it whatever we want to call it. But at the start, something needs to get done. Okay, we'll do some back and forth with the client or whoever has initiated this process to get a good understanding of what they want. So we'll have interactions with the client to gain a thorough understanding of exactly what they want us to be able to do. And we analyze their request so that we have this thorough understanding. And then from there, we plan it out, step by step, what it is we're going to have to need to perform whatever this task is that we're going to have the computer perform. We do a thorough analysis of all the requirements, every little aspect of it, and we get it all mapped out in a rough form. And then once we've got it mapped out in this rough form, then we start formalizing it in a design phase. And we may write some pseudocode. We might actually write some code to perform whatever that task may be. And then we'll implement it. Say, all right, here it is. This is the code that does what we wanted it to do. And that's the implementation phase. And once we get to that phase, we're not perfect. And I don't want anybody to fool themselves thinking that they are perfect. We have run into problems along the way. We misperceive things. We overlook things. And one of the biggest hurdles in programming is thinking everything we do is 100% right. Oftentimes what we do is spot on 100%. But not all the time. And inevitably, we have to go test what we've done to make sure, does it actually do what it's supposed to do? Will it work with the other systems that it has to interact with? So that's this phase 5. Okay. Now once we get through phase 5, we make sure that it's going to keep doing what it's supposed to be doing. Now, this part right here, the testing and integration part, if this does not go the way we plan it to go, then we have to come back and do or revise what we've done. It's all right, found some problems. How are we going to address them? Let's analyze a little, redesign, re-implement. So we call it a cycle because it may take multiple iterations before we're successful and get to the maintenance phase. We may, if we think about an operating system, we see Microsoft releases different versions about every 3 years. Here's a new one. Well, they found improvements. So instead of revising that one, hey, we're just going to start building a new version of it and release it as, here's version 2, here's version 3. That's a common practice. Okay. So if we're going to start programming, somebody's going to tell us what it is they want us to do. The professor may say, hey, here's your task. Your project for this course is that you create code to do whatever they may want it to do. So we'll go through and we'll create some pseudocode. Once we've analyzed what it is they want us to do, we'll create some pseudocode. So we'll enter a value, and then we're going to test to see if that value is greater than 10. And then we'll say, hey, your number is greater than 10. And if the value is less than 10, we're going to say, and we'll go through and we'll lay out step by step A lot of times people will call this like creating the recipe, the step-by-step, how to do a certain task. Much like if you're going to make a sandwich, here's the step-by-step how we're going to go about it. Now, different people may make a sandwich in different ways, and those steps may vary from one to the next. So this is, think of it as a rough version. Once we get past the pseudocode, we get that figured out, here's what we're going to do. We're going to go test it, and we're going to test it with the logic of what it is we're wanting to do. I'm going to make flowcharts to test the logic. Pseudocode to get the organization out of the way, and the flowchart to deal with the logic aspect. Because if there's a flaw in our logic, the processes, the dependencies, whatever it may be, it generally comes out, comes to light, when we test our logic with a flowchart. I've got flowchart software that allows us to create this step-by-step progression through our project, whatever it may be. We start, turn the thing on, scan the environment, generate a map for locations, plan our route. What's our route going to be? And then it goes through and it does it. And that's a flowchart. And there's different symbols mean different things. I'm not going to dig deep into it in this video, but I just want you to get an understanding of the different processes that'll take place in computer programming. Different ways to check for different errors. So the pseudocode is, here's my plan, here's what I'm going to do. Here I go test to see, is there a flaw in my logic? Once I've got that done, then I'm going to want to go program it. And how do I program it? Where do I program it? Here's what we'll call an IDE, an Integrated Development Environment. This is web-based, and this allows me to interact using different programming languages. This one happens to be using Python. Python's one of many programming languages that allow us to create programming code to perform whatever the task is that we want to do. Now, some programming languages are better suited for specific tasks than others. The predominant data analytics software currently is Python or C++. AI, we see a lot of Python programming taking place. You say, well, why would we pick one language over another? Well, it has to do with the design of it. I'm going to say the design of it. Well, am I the one creating the code? Well, in a way, you are creating the code, but the software applications or the languages that we're going to use in different programming courses, they use what we'll call libraries to perform tasks. So you see this print function. Well, there's a library that exists that has different functions available to me to perform tasks. Think of it as built-in functionality. Print something, input something. Well, I don't have to write the code to interact with the hardware to print. I don't have to write the code to interact with the hardware to input. Somebody's already created a library of code to do that for me. And all I have to do is call or invoke the print function, tell it what I want printed out, and it'll do it for me. Now, these libraries are designed to perform specific types of tasks or functions. They may not come built into the general IDE that you're using. You may have to import them in. You may have to use some software to add it into your computer just to be able to use it. In many cases, what we'll do is up at the beginning, I've got a comment here to say, here's what we're going to do. This is an intro to program for COP1000. There's a comment, and here's a call to a function. I can put a statement up above that tells the computer, go get this specific library because we're going to need it for some work we're going to do. So one of the key things you need to take away from this is there are different languages we can use. Java, variations of the C language, say the letter C. So we could have C, C++, C#, Objective-C. Each one, think of it as its own dialect of a different language of C. Java is a totally different language. Some similarities to C++ and C#, but not 100%. So there's a lot of different languages that are out there that we could use. We pick the right language for the specific task we're going to perform. So think about it, the right tool for the right job. If we're using or creating something for an artificial intelligence program, I may want to use Python. That's the most commonly taught language today and one of the most common used in AI or data analytics today. When we look at programming, I'm going through this sequentially, step by step by step. Now, I could have a language like C. It is totally sequential. It's not an object-oriented language. Whereas Python is an object-oriented language. And it allows me to reuse code or create instances, clones or copies if you will, of some code that's already been written so I can reuse it. I'll talk more about that later on in the course, that differentiation. Just know that there's different types of code, sequential and object-oriented. There's different languages, C, C++, Java, C#, Python, R, variety of different programming languages. We need to know which one we need to use to perform specific tasks. We need to understand the different steps of software development life cycles, the different phases or stages. Understand that we're not always going to be perfect, and we may have to test, debug, and go back and try it again. Might have to revise multiple times. One of the common things that I like to tell students is when you're programming and it's not doing what you expect it to do, sometimes you just need to pause, stand up, walk away, have a sandwich, have a glass of water, get away from it 5-10 minutes, and then come back and look at it with fresh perspective. And all too often, that issue becomes so obvious. All right. So we'll have to debug, revise. We go through this design code. We document everything. We test it to make sure it's doing what it's supposed to do. And then we do that integration to make sure what we've created works with everything that it needs to work with. If we're really good at what we do, we may create our own libraries for Python or C Sharp, whatever it may be, to perform specific tasks. And over time, those libraries become commonly accepted in the industry to perform those tasks. Okay. So you'll, over time, understand what specific libraries are used for, what languages need to be used for certain things. What's the difference between you writing code and AI writing code? It's something that you'll need to think about as you go through the course. You may be able to use an LLM like Bard or ChatGPT. Say, hey, create this code for me so I don't have to write it. 80% of the time, it's likely going to be wrong, depending on the complexity of what you want it to do and how you write the prompt. So now, in today's environment, we have software that's been created that will write software for us. It's only as good as the resources available to it. So when we think about this testing and integration, if somebody chooses to use AI to develop software for their homework or whatever, just know AI doesn't test it. AI says, I planned it, I analyzed, I designed, and I implemented. I don't do step 5 or 6. Right. You're going through the entire cycle in the courses and in the projects you're going to work on. Okay. So just understand how AI works and the fact that we have it available to us. We have it available to answer questions for us. But it's one of those, we have to understand what it is we're doing, why we're doing it, so that when the time comes, we can actually test it and fix it when it doesn't do what it's supposed to be doing. Okay? So there's a little quiz associated with this that'll ask you some questions based on what I've talked about. All right. Have a great day, and thanks for taking the time.